We are going to go over series relay pumping and a few other items you will need to know to pump sprinkler standpipe connections. With the fire department connections on the outside of the building, we have two different kinds. We have combined and separate. Combined connections on the outside of the building support both the sprinkler and the standpipe system. Separate fire department connections will have one for the sprinkler and one for the standpipe. We will always charge the sprinkler system first. This helps with reflex time to getting water on the fire a little bit quicker. High-rise buildings equipped with working building fire pumps will do all the work. Our pumpers are backup in case of failure. Check valves are present if there's more than one way to receive water into the system. This keeps the pressure from the building suppression system off the connections on the outside of the building. To open these valves, you must pump at a higher PSI than was being produced by the building fire pump or system pressure. When pressure reducing valves and pressure reducing devices are present, and we need to take the system over, we will set our discharge pressure to the top floor. When calculating pump discharge pressure, we're going to start with 20 psi for the friction loss at the connections, then 80 psi for 4 sections of 2.5 inch, then 5 to 7 psi per floor above the first floor, depending on 10-foot or 12-foot ceilings. These calculations are not exact and may need to be increased depending on the building system design and hose length. If we have a fire on the 41st floor, I start off with 100 psi for the first floor. That includes the 20 psi for the friction loss on the connections and 80 psi for the attack hose, 200 feet worth. I then add my 5 psi per floor, which is going to be 40 times 5 equals 200 psi. I add the 100 to that for the first floor. That gives me 300 psi discharge pressure. Moving to the pump panel. RPM mode is used for relay pumping, feeding a truck, and charging the sprinkler standpipe systems. PSI mode is used for pre-connect hand lines. KCFD uses single stage pumps. When we add a pumper between the hydrant and the attack pumper that has the hand lines going to the building fire, we're creating a two-stage pump. So the supply pumper at the hydrant will take the city water pressure in, increase the pressure, sending it to the attack pumper, where the attack pumper will take that and can increase it even higher. This is better on our pumpers, allowing each pumper to share the workload. Now we're going to show a demonstration of series relay pumping at high rise. The first arriving pumper to the connections is going to be the attack pumper. The goal is to spot the attack pumper no more than 100 feet from the connections. Place the attack pumper in pump gear. Advance your 2.5 hose to the sprinkler standpipe connections. When you make it to the connections, you'll need to remove or break the safety caps at the sprinkler standpipe connections. You can use a screwdriver or a spanner wrench. This is also a good time to check for debris in the connections. If the female connections do not rotate, you can use a double male and a double female to make the connections function properly. Attach the hose to the sprinkler standpipe connections. It's better to make connections to both sides of the sprinkler standpipe connections, just in case the clapper is stuck or leaking. When dealing with high discharge pressure at the connections, we need to tie off the hose to prevent injuries. The next arriving pumper to the connections is going to be the supply pumper. The supply pumper will stop at the attack pumper and reverse lay to the next closest hydrant. This is the best time to move the 4-inch supply line to the side so we don't block the truck or other apparatus trying to enter the scene. When the supply pumper arrives to the next closest hydrant, we're going to place the supply pumper in pump gear. The first thing we're going to do when we get to the hydrant is make sure it's in service and we're going to flush it. The goal is to park the supply pumper no more than 100 feet from the hydrant. Preferably, you just want to be one short section from the hydrant to the pumper. Connect the big yellow that was reverse laid from the attack pumper to the discharge on the captain's side. Now you can charge the hydrant going to the supply pumper, and you can wait for the attack pumper to call for water. When the attack pumper calls for water, slowly open the large diameter discharge. With high rises, the goal is to have the supply pumper less than 300 feet from the attack pumper, but no more than 500 feet away. If the supply pumper is more than 500 feet away, we're going to add another pumper between the supply pumper and the attack pumper. Place the supply pumper in RPM mode and wait for the attack pumper to communicate if the pressure needs to be increased. Make sure the large diameter hose is routed away from the exhaust, just in case the pumper goes into regen. With the city water pressure coming in the supply pumper, the pressure is increased to 45 to 50 psi just at idle. When supplying the attack pumper, make sure the intake pressure gauge does not go below 20 psi. Max discharge pressure for 4-inch big yellow supply hose is 185 psi. The supply pumper will need a monitor pump temperature. Now we're ready to charge the connections at the attack pumper. Place the attack pumper in RPM mode. Now we're going to slowly charge the connections up to 150 psi. The reason we're starting at 150 psi is to see if the check valve is closed and the building fire pump is working. After holding 150 psi at the connections for about 30 to 60 seconds, slightly gate down. If the gauge does not move down, this is static pressure. This means the building fire pump is working and that the check valve is closed. Return the discharge to open and idle down and just be in a standby mode. If the gauge does move down, this is flowing pressure. Calculate your discharge pressure to the fire floor, radio to the supply pumper to increase pressure, and return your discharges back to the open position and pump the system. You'll need to let command know. Remember, if the fire tech group finds pressure reducing valves, we will pump to the top floor. With high discharge pressures, we're going to need to monitor pump temperature. Booster lines can only flow 45 gallons per minute. Consider using the bumper line. Water as Pumps recommends 100 gallons per minute to keep the pumps cool while under high static pressure. The pump overheat light turns on at 180 degrees. Monitor pump temperature by placing your hand on the side intake. Recirculating the tank and using the pump cooler is not going to be enough to keep the pump cool. Here is an overhead view of the supply pumper at the hydrant pumping to the attack pumper. Hope this video helped you understand series relay pumping and how it can be applied at high-rise fires and fires that hydrants are long distances away.